Welcome everyone. Welcome to our session. I am Aryan Mehra, and today we are going to have a great session on career in semiconductor industry, especially for the physics students. So every day we are looking for new careers. Okay, every day the field of technology and science are moving towards some latest trending fields. And what is a trending field of what is a current trending field? One of the current trending field is semiconductor industry, which is going to grow exponential in coming years. And how you can get into this semiconductor industry, and as a physics student, can you get into such higher technology industry where you do not have much experimental skills till now, because BSc and MSc does not give us the technical tools which gives us the jobs in the industry itself. And what is nanotechnology, and how nanotechnology is connected to semiconductor industry, right? All these questions. What are the kind of jobs I can get? What will be the salaries for those jobs? What kind of research opportunities are there in this industry? What are the institutes where I can join, and how I can join those institutes? All these questions. So today I'm going to open a very black box for you, and in this box is the semiconductor industry for you. And once you see that, I'm very sure that you are going to get a very much motivation to go into this industry, because this industry has not been seen by the physics students till now. I also came to know about this industry and this department where I am currently doing the PhD just before I joined this department. Okay, very few months before I actually applied, I came to know about this department, and still many students don't know. And because of that, I'm making this session live for you. And this session is also available on YouTube after the session will be over. Okay. So just a quick introduction. I'm Aryan Mehra. I have done my master's in physics from IIT Delhi last year. And now I am a PhD student at CeNSE. What is CeNSE? CeNSE is Center for Nanoscience and Engineering. So nanoscience and engineering both. It's a interdisciplinary department. So the people here are coming from various backgrounds, from physics, some are from chemistry, some are from mechanical engineering, some are from electrical engineering, but mostly people are from physics background. So all people connect together. Faculty members are also from different kind of disciplines. They connect together, and they have built this department where different kind of research is happening. So this is a very interdisciplinary department, and it is in IISC Bangalore, which you all know is a Makkah of research and science in India. I would say there is no best institute than IISC. I have made the detailed video of IISC, specifically IISC, that what is the facilities there for a PhD students and other kind of students coming to this institution. Please check out that video also. But today we will discussing the sense, and more specifically the semiconductor industry. Okay, so I am a PhD student in quantum matter lab. Okay, my supervisor is Dr. Chandan Kumar. And if you want to connect with me, these are the details of to connect with me. Join our Telegram channel, Physics by Aryan. Go to our website, or you can even call me. Okay, just put a message and then call me. You can drop a mail as well. So let's just begin. Okay, let's just give you an idea about this thing. So this let me start by telling you what is nanoscience and nanotechnology. Okay, so all these images will be very new to you, and it was also new to me. I had no idea what these things are, and luckily the department was able to teach me very nicely about all these things. So what is nanoscience and nanotechnology? I don't want to go into the definition part, that nanoscience is a science of nanoparticles, nanoscale things, that you can easily guess that if I am saying nanoscience and nanotechnology, everything we will be working is will be in the nanoscale or at max micrometer scale. And what is micrometer scale? The hair diameter, the diameter of your human hair is roughly 100 micrometer, 10 to 100 micrometer. So even smaller than that, the thickness of your hair, the entire device which you will be studying. So what is device? What are real time devices? For example, your digital clock is a device. Okay, for example, your toaster is a device. Your uh, all sort of mobile phone is a device. So the devices we are talking here is thinner than the human hair. That is a scale where you have to go and do the engineering, study the science at such small level. You have to go and do control the things, engineer the things. Where do we see this nanoscience and nanotechnology? So number one, chip manufacturing. Currently there are only few companies which are the leader in the world. For example, TSMC. Okay, TSMC is in Taiwan. These are the kind of companies which there are many few. Intel is one of the example. Okay, chip, what is chip? Chip is a very small part, is a brain of a computer or any electronic device which controls the entire computer or that electronic device. And in this there are many sort of electrical components are there, many sort of transistors, gates, logic circuits, so on. All the things which your computer has is in there. So in just one micrometer there are millions of transistors placed. In just one chip there are millions of transistors. How do you put such high number of transistors in such a small space? You can imagine that. You can't even imagine ki what is going on here. How do you make such small things and perform so better? And you can actually see the tools that with which these kind of chips are made. Okay, then where do we see 2D material devices? This is a very new term, two-dimensional material. This is where I am working in. What is two-dimensional materials? We know three-dimensional materials, right? Everything around us is a three-dimensional. So the atoms are arranged in two-dimensional, and even in the height it has some sort of height. So aluminum, all the wood, everything which you're seeing around is three-dimensional. Now let's go to the two-dimensional. So the layer of atoms which is only two-dimensional, there is no height of that, no thickness. So how the electronic properties, optical properties, mechanical properties of such materials will change? And if we study those materials, can we replace these materials with the actual silicon? Silicon is a silicon industry, right? So semiconductor industry is also called as silicon industry because silicon is a semiconductor. So can we replace this silicon with two-dimensional materials? So the answer is yes. There are many things, many materials which are replacing the silicon in very specific applications where silicon does not give a very good performance. Okay, for example, if you want a very good energy efficiency, okay, then we use gallium nitride. Okay, GaN technology, GaN technology. Okay, GaN technology. Let me tell you this. This is a very important actually. Many startups are getting open just on the basis of gallium nitride technology. I am working on graphene. Okay, there are many other materials, TMDC, so on and so forth. So this picture which you see is a one transistor, just a one transistor made with a 2D material. So this transistor is made just to see the properties of 2D, two-dimensional materials. And there is so much exotic physics which happens here. For example, when you see the 2D materials, they have almost very less resistivity, no resistance. And at the same time, if you change some things in this, very few things, it becomes a completely insulator. So it can jump from insulator to superconductor, and you can just tune this very finely. So such exotic physics people are doing, and this is not just a textbook. Nothing which happens in nanotechnology or specifically in our department of sense, nothing is textbook. Everything is experimental. Okay, you have to do the experiment and tell that okay, this is happening. You cannot just predict the theories. Okay, so where else we see these things? Biosensors, gas sensors. Okay, biosensors. What are the biosensors? Okay, so there are some sort of DNA detection is there. Can you do this? Can you measure the, just can you have some sort of medical kit in which you can measure all the parameters for which you have to go to the clinic? You have to pay a lot of money with all the test, all the infection test, and protein, what is the protein levels in your body, what are the vitamin levels of your body. Can you do all of these things at home? So the answer is yes. If you use the nanotechnology to make such things, they are so sensitive that they can even detect a very smallest amounts, and you can just have these devices at your home. So startups are getting built on this technology, right? Solar cells are there. So Now you know the solar cells which are based on the which are very traditional solar cells are not very much efficient. So to increase the efficiency, to have a very good efficient solar cells, again nanotechnology based solar cells are there. Okay, so these are the images which I have put. So these two images which you are seeing in the bottom is what I do. So here you can see there I am studying the two-dimensional materials. What are the physical properties of these materials? So how do I do that? So first of all, just to give you an idea, this entire thing will be 30 micrometer. So 1/3 of your human hair, just 30 micrometer, this entire thing. Okay, this is called HBN, boron nitride. If you don't know, it's an insulator. Okay, and then this blue is also HBN. So why you are seeing two colors? Because the thickness of both are different. Okay, and in between there is a graphene which I want to study. So you can clearly see this, right? How many of you can see the graphene in between? That's the dark part, third part. Can you see something in between this thing?
Yes, sir.
So you can see this is what I want to study. And what is the size of this? Just 10 micrometer. On 10 is also very big. I think 5 to 7 micrometer. 5 to 7 micrometer. Just think. And let's think now how you will. This is not a simulation image or any diagram I have made. This is an actual experiment I have done, and I have stacked the three layers. So just imagine picking one two-dimensional layer, then picking another two-dimensional layer, and keeping on top of each other. How do you pick such small things? And then third layer and just close this. How do you do such precise engineering? This is a art, and how you can do that. And just like I was a physics student, I had no idea. If I can do it, you can also do it, right? And then it's not enough. This is just the one part. I cannot study electrical properties of this. How do I study the electrical properties? I have to give some current. I have to give some voltages. How can I give the current and voltages? In real life, we have plugs, right? Plugs are very big. I cannot put a plug here, right? Plug is centimeter, meter size. Okay, how do I give the current and voltages? So can you see here in the first diagram all the pins going, electrical pins going, right? This is a gold contacts. How do you make such gold contacts on this? So this is a machine called e-beam lithography. Third image, e-beam lithography. You have to learn this tool. So you use the electron beam to make the contact. So you can imagine the kind of engineering you are doing. You are making the electrical contacts with electron beam, such a small beam. And these contacts are of the nanometer size. What is nanometer? Nanometer is just 10 atoms. Just 10 atoms gives you nanometer, such small. And then you fill it with the gold, and then you give it voltage and current, and then you study the properties. So this is the level of engineering I'm talking about. And when you do the physics at this level, interesting results. For example, how many of you have heard the word mobility? Mobility, have you heard ever in your life?
Yes, sir.
Yes,
So what
sir.
is mobility? Can anyone tell me very
Yes,
quickly
sir.
what is mobility?
It's direct velocity like after electric field.
Related
So
to
Yeah,
movement.
basically,
yeah, tell me what is mobility. Very simple one. No physics diagram. That definition.
mobility basically like the electron moving in the conductor.
So how easily electron can flow inside anything, right? Inside a channel, right? How easily it can flow. This will give you mobility, right? How many of you agree? Yes,
Yes,
no? Tell
sir.
me. So if
Yes,
your
sir.
silicon has mobility of few hundreds or few thousands, then this material will have mobility of 1 lakh. So just imagine if this comes to your home in an actual device, your power consumption will drop by so much huge amount. So this is what the power of these kind of devices are. It is not being studied just to get some papers, just to have some patents. It is being studied to solve the problem of the mankind. Okay, these were the few of the examples. Let's see where else do you see the nanotechnology, just to give you an idea, more idea. Okay, UV optoelectronics. Optoelectronics is also one of the very famous field. What is optoelectronics? Where you have an optical properties and electronical properties. You use light to have some electronic properties, you use electricity to have some optical properties. So your devices in which both optics and electronics is involved, where such things are used for the water purification. You see, can you imagine purifying the water with light? Purifying the water with light, we purify the water with the chemicals, and we heard that okay, these or RO companies are not good, okay, these is not good, reverse osmosis is not good for health, that's and so on and so forth. It extracts out all the minerals, okay, and you are not getting a good water. Just imagine purifying your water at any place in the world just with the light, if you have a small device in your hand. Then think about UV detectors for missile launch detection. You want to see the very exact trajectories of the missile launch, and you will have some cameras which can give you that idea. How much heat was flown out, all the things. Then optical sensing, integrated optics, lasers, photonics and materials, optical communication. Okay. Now, if we go to the bioscience, biotechnology side, not biotechnology, I would say bio nanotechnology. Nano needles. If we can make the needles whose tip is of the nanometer scale, you can ask any bio person that how important that is. And which images you are seeing here is the SEM image. Okay, so we use electrons to see the nano needles. Okay, because we cannot see nano needles with light. Can anyone tell me why we can't see nano needles with light? Tell me very quickly.
I think
The T is smaller than the wavelength of visible light.
Yes, in order to see
Size
something,
of photon.
yeah, your wavelength of the light should be lesser than the needle itself. But but tell me, what is the usual wavelength of the light? 500 nanometer, right? 500 something nanometer, right? But what are we talking about here? We are talking about nano needles. So we need electrons wavelength, electrons de Broglie wavelength to see these needles. So if someone gives you nano needle, you will not be able to see these needles. And then just making these needles and not all, and then again using these needles, right? Then MEMS and NEMS devices. What are MEMS devices? So you all know your phone, mobile phones, right? If you do in landscape mode, it remains in landscape mode. If you rotate your mobile, it turns into portrait mode. Okay. So these kind of functions which your device is doing. NEMS, MEMS means mechanical and electronic devices. First we did optical and electronic, now mechanical and electronic. So where mechanical motion is detected in terms of electrical signals. So this is what is happening, right? You're turning your device and your device knows that I am being rotated. So these kind of devices are in all the mobile phones, all the laptops, and you will learn how to make these kind of devices. And even better, 5G filters. Okay, 5G filters. So one of the biggest problem in making 4G, 5G, 6G is filters. When you have such sort of wavelengths coming into your mobile, how your mobile will know? That is why your mobile have, right? This mobile is portable with 5G technology. This is with 4G technology. How? Because there are 5G filters put inside that mobile phone. How do you make those filters? This is entirely MEMS. And is it just a textbook? No, it is being made. There are professors who are making this. And if you make one 5G filter, then Intel company, HCL company will, if that your filter is good, will purchase at the millions of dollars, not just few dollars, not just few $1,000, millions of dollars. Okay. So this is a level where I'm talking. That is why this industry has so much money, right? There is no funding problem at all in our department, right? Let's move on. So these were all the very brief idea I gave you. Okay, this is huge amount of semiconductor technology is there, but I have put a few of them just to give you an idea that it is a technology driven. So it is your way to go from physics to technology and still do the physics. Okay, I'm still doing the physics, I'm still studying the physical properties, band structures, all those things, valence band, conduction band, but now I'm not doing that on the notebook. I am connecting all those information with an actual applications, okay, or actual experiments, when someone says this is valence band, this is conduction band, now I do not say this is valence, this is conduction. Now I say, give me the experiment where I can see that this is valence, this is conduction band. How experimentally you can see these things? This is okay. Whatever is teach in the notebook is okay, but how do you experimentally see this? And these are not the experiment which you show on some kids show, right? These are the experiments which need a very expensive tools to perform. Okay, so where do we make all these things? Where actually nano, so this was about what is nanotechnology and nanoscience, what are the things related to it. Now I will go where this nanoscience and nanotechnology happens. Where does this occur? So this occur in a clean room. So if you don't know what is clean room, let me give you an idea. So there is one NNFC, National Nano Fabrication Center in IISC. It was made in 2014, officially inaugurated in 2014 by our Prime Minister Narendra Modi. He was recently joined and he inaugurated this. Clean room is a place. So just to give you an idea, I told you that all the devices are of micrometer scale, right? Micrometer, less than that, even less than micrometer. So your dust particles are also of the same size. So you cannot tolerate the dust because one dust particle is equal to the size of your actual device. So just imagine you have a refrigerator, right? And close to your refrigerator, there is a dust particle which is of the size of the refrigerator. Can you tolerate this? Can you tolerate this? Tell me. So refrigerator is there and close to refrigerator, there is a dust particle which is of the size of refrigerator. So it is impossible, right, to work here. So how do you work in such devices, right? You first of all, you have to eliminate all the dust particles. How do you do that? You work in a clean room. So clean room is a very big place. There is one of the biggest clean rooms, not just in India, of the world standard clean room. It is a class 1100 clean room for overall, and it is class 10 clean room. Oh no, sorry, class 1000 clean room overall and class 100 clean room for the lithography. Lithography is a place where you actually write with the electrons, right? I just mentioned, I learned that tool. Okay, where you write with the electrons. So that is class 100. What is class 100 means? Only 100 dust particles are there, less than 1 micrometer, sorry, greater than 1 micrometer in one by 1 liter. In 1 liter volume, there are only 100 of such particles. So this is the cleanest. If you imagine with your actual surrounding, it is 1 lakh. So reducing from 1 lakh to 100, you need to make a clean room. And there is an entire process of making the clean room, which the top people, top experienced people have come together and have made this clean room. In this clean room, there are many sort of tools. At least more than 50 to 70 tools are there. You have lithography. You have lithography. So lithography is a new word for you. Lithography means, so whenever you see a chip, right, you see something is there, right? How you make the transistor? So you make the transistor by using lithography. So there is one way is write with the electrons. So we called it electron lithography. If you do it with the light, UV light, then you do ultraviolet lithography or optical lithography. Then you have the tools of etching or so many. I don't want to give you words or something, but there are so many tools which are essential for any process, that all are available here. And every year new tools are coming. Still new tools are coming. So does having the tool is enough? So are the tools which are available here, if we learn those tools, if we work on those tools, what is the benefit? So the benefit is the industries are also working on the same tools. Industries also have the similar tools. They also manufacturing using the same tools, but at a very large scale. Okay. So if you know the tools here, the company will say, okay, you know the tools here, come to us, operate the tools at our place, please find out how we can have more efficiency. Please find out what are but better we can do. Please troubleshoot the problems, because every day new problems comes and companies need expert minds who can identify how the problem originated, how we can solve this problem, and how we can again come to the efficiency which we need, how we can engineer the processes, how we can have the physics, what is the physics going on behind any process. Okay, when you are making some sort of, let's say you are trying to replace silicon with some other materials, so you need a people who know all the physics behind it. You know the people, you need the people who know how to use the tools to make such devices. All those tools which are needed in the industries are actually here. And if it is here, can you learn that? So answer is big yes, because for every tool there is one FT means facility technologist. For every tool there is an facility technologist, and there is a website of CeNSE, okay, which you cannot access. This is a means intranet website, which can only be accessed with the IISC email addresses. Okay, this is not open for everyone. So you can book the tool. Simply you can book the tool and it will be charged, but not to you, but to your department. You don't have to pay anything. And this FT people will teach you. And then you can work on these tools as much as you want, and you for whatever is needed for your research, and you have to talk with your supervisor and work with it. So you, it is very easy to learn any tool, very easy. They sit with you, they teach you the tool, such a complex tools they teach you, and then they make you perfect in that, and then you can independently use the tool any time of the day. I go even in the night, 12 a.m., 3 a.m. to use these tools. No stopping at all. You can go anytime, use the tool until unless it is not booked by someone else. So you have to book the tool and then go and use it. Okay. So this is all happening in the clean room. I would suggest you to go to YouTube, to nanoscience department, and watch their video on clean room. Any question till here? Then I will move forward. So
No,
yeah,
sir.
yeah, tell me.
Sir, I have
Tell
a
me.
doubt.
Yeah.
If there are limited number of tools, then is there any trouble to book in the tools? To book for the tools? Like,
See, yeah, definitely not much trouble. See, sometimes what happen is in the working days, right? From 10 to 5 p.m. Okay, 10 in the morning to 5 p.m. The tools are heavily booked because nanoscience department also caters the people from outside the department. Okay, they cannot work independently. They have to work in the presence of FTs only. But you can work independently, so you can book the tool after working hours. So after working hours, tools are mostly free. Not all the tools, few tools are very heavily booked, so you have to book in advance. I usually, what I do, I book one week before. So whatever I need to use up next week, I book this week. So somewhat you have to be active, but not much problem is there. Most of the tools are free after working hours. You can easily go in the peace and work in peace there. No one is stop. You can work in clean room for 10 hours, no problem. You have to go in such gowns. You can see the person in the gown, right? On the left hand side. So in such clothes, you have to go inside. And after a few times, you get comfortable. So not a big issue. Not big issue. Any other questions? So far till now, everyone is with me. Everyone enjoying the session till now, or energy has been
Yes,
dropped.
sir.
Yes, sir. Definitely.
Everyone is getting to know new things, or is it boring, just like old textbook?
No, no,
Nothing,
no.
right?
No, sir, it is very interesting.
Good. So okay, if it is interesting, tell me, once you have the device, right? So think like this. You have to measure the electrical properties, optical properties, mechanical properties. What are the measurement tools you know? Can you name any measurement tools? These are the measurement tools. If it gives you any hint, you can see. Can you tell me any measurement tools?
Are you talking
sir,
about
as far as
microscopy?
What? Just give me one name. What?
I can
sir,
talk scanning atomic force microscopy.
Optical
And the
force
photo
atomic force
you
microscope.
determine.
AFM, okay. Atomic force microscope,
Yeah,
I got
yeah.
one. What else?
Optical bench, sir.
Optical bench, very nice, very nice. What else? What else? Give me the
Electron
name.
microscope.
Microscope, very nice, very nice. What else? Just give me the name. Raman spectroscopy.
Illumination spectroscopy and
No,
Raman spectroscopy as well.
Raman
Yeah,
spectroscopy,
Raman.
yeah.
XRD. XRD नहीं सुना? XRD.
Yes, sir. Suno.
Yes,
What else you can think of? How you measure electrical properties? Think about this.
Scanning tunneling microscopy.
Okay, SEM,
mm,
STM. Okay, what else? So you cannot think of even a single name which is not here. So it is called MNCF. In one department, there is one big clean room, which is NNFC, and there is one big facilities, which is MNCF, which is characterization facilities, where you do the measurements. So more than 50 to 70 tools are also available here. Once you make the device there, come here and measure. Not even a single device you can imagine which is not here. Maybe very advanced one if you go, maybe not there, but most of the tools that you will hear in your textbooks are available here and easy to use. It's not like that, okay, I need to take special permission, so on and so forth. Similar way, just book the tool, FT will teach you, learn it within few times you learn, then use it independently any time of the day. All the tools, just imagine, is there any place in India where you have all the tools under one roof? You don't even have to leave the building. I bet you to give me a single name where this is the situation. Can you give me any example? Yes, no? Have you heard anything
no,
like that?
sir.
And just
No, sir.
imagine, my every month bill is 70 to 80,000, which department is paying for my training, for my training, for my using of these tools, for my learning of these tools, and no questions asked. No one says, okay, why are you using this tool so much? No questions asked. If you use the tool more, people appreciate you more, that you are doing the more work, even though it is costing them money. Can you imagine such a good ecosystem? Can you learn anything more than this anywhere? It's not possible. Not possible anywhere. Even if you go to IITs, even if you go to IISERs, there are facilities are definitely there also, but some facilities are in one department, one office, other are in some other department, and then there is a lot of booking issues, lot of learning issues. You have to find the people who can teach you. Here nothing, people are there, just book the tool, they will teach you, go there and work. Only problem here is time. So just imagine, you have so much opportunities and you don't have time. That's the only problem. So you are not even sitting for one moment without learning. Okay, so this was about MNCF. So one is NNFC, where we make the device, which is clean room. This is not a clean room, this is a characterization facility. Okay, here the normal environment is there. Then there are our own personal labs as well. Means every supervisor has their lab, and in those labs also we have a specific tools for us, which is very much specific to the research which that lab is doing. And those tools are also very expensive, very new, and which are not available in MNCF or NNFC. So those tools are also there. So most of the times you will be using those tools, then the tools of MNCF, then the tools of NNFC. So you can imagine NNFC, MNCF, and those tools. So do you think there will be more, even more, or is it enough? What is your guess? Do you think there will be more tools than these, or other? There are more actually. There is also called packaging lab. So what, can anyone know what is packaging in terms of semiconductor industry? No, right? Yes, no,
Oh,
anyone?
I think coating the semiconductor device with some insulator to protecting from the influence of outside atmosphere.
Yeah, that is
Am
one
I right?
idea. That is one idea. One is packaging is used to protect the devices. That is a very simple idea. But the packaging in itself is a lot. Okay. So how you finalize your device? You have to you have to put it somewhere. You have to pack it somewhere. All the wires are there. And wires are very small. Okay. How you put the wires? Okay. Let's say how you put the plug. You make a some refrigerator. In refrigerator behind there is a plug, right? And you connect it to the power cable. Now think that plug is micrometer scale and your power is also of micrometer scale. How do you connect that? Now you cannot use electron beam, right? How do you connect the wire from your device to the power source? So these are you done by gold wires. Gold wires are of 25 micrometer thick. So less than your human hair thickness, you have to connect the wires from your actual device to the power supply. And those power supplies are also not very simple power supplies. These are lock-in amplifiers, source meters. Every power supply costs you more than 5 lakh, 6 lakh rupees, even more than 10 lakh rupees, right? And then you have to connect those wires to that. So that there you need packaging lab. So packaging lab is also there, right? You need ovens, you need furnaces. These are the simple tools which are available, which are only available, means only these kind of tools are available in simple universities. But here these tools are just like extra tools which we need. Okay, put it 4 5, anyone can go and use. So these kind of tools are anyway very simply available. Ovens, right? All sort of things. Soldering stations, right? There are so many soldering stations you can just go and use. Okay, packaging lab needs soldering station, wire bonding. These kind of things are there. Every day you are learning. Okay, so you know PCB design. PCB, anyone know what is PCB? PCB everyone should know. PCB नहीं सुना क्या कभी? PCB,
Yes, sir.
electrical boards, right? All the physics student, electrical board, right? When you open something, right, refrigerator or something, there is a PCB in which everything is written, right? PCB, and PCB engineers take 5,000 rupees just to fix one PCB, right? And these are just electrical engineers. So you can learn to design PCBs here. Learn to, and there are dedicated people who will teach you. Have anyone know about the microcontrollers? Microcontrollers.
Yes, sir. Yes, sir.
Microcontrollers you can
Yes, sir.
learn. Microcontroller is sort of a separate degree which is done by the electrical engineers. Specialization microcontroller, and you can just go and learn. There are people, go to them, just tell them to teach you. You have a specific project in mind, they will help you. So just imagine everything is here, just one place, and you can learn anything at a very easy. And if you are learning, it is not like they are feeling you as a burden. They will appreciate that you are learning. More hours, number of hours you put in the in the department, more you learn and more you get appreciation. And everything you can get at a one roof, under one roof. No need to step out of that department. No need. Okay. So now, uh, before I start my career after PhD and so on, I just want to quickly give you my experience. Okay. So that I can end the highlighting about the department, and then I can directly go to the jobs and all parts. So what was my experience here? So I was just like you, physics student, no experimental skills at all. I didn't even use the microscope before. My project in MSc was completely theoretical. Still, I got into this department because of my knowledge in the interview. So all of you can qualify. There is no questions asked about the nanotechnology. Only your physics should be good. That's it. If your physics is good, especially condensed matter physics and electronics and some part of quantum mechanics, if it is good, you can get into the interview. You can qualify the interview. They only see, are you able to do the hard work? Does your CV, not CV, I would say, your answers of the questions are showing that you have done hard work in your life. Okay. Then, and how much interested you are about this field. So before going, just look into this field. If you get a chance to give an interview, Look into the field. I have also telling you these kind of things no one told me at that time, so I'm just giving you that. If you can mention these things in the interview, they will directly hire you. They are only seeing how interested you are. Okay, because not many people know about this department. So what was my experience here? So from the very first day I can tell you, when you enter IISC, so welcoming environment. IISc is, I don't know why it is so much criticized for bad mental health and so on and so forth. All those are bullshit newses. Okay, very welcoming environment. They give you a single rooms, perfect mess. I am eating in the mess from last 7 months. I have not got bored from my mess food. Such an good food. Single rooms. Okay, no restrictions at all. You can get whatever you want. Or if you want to put an oven, if you want to put an kettle or induction, you want to, that's all things are allowed. Not officially but unofficially allowed. Okay, then you have a wonderful people here. Many teachers even say don't call me sir, even though you call them sir, but they don't like call being called sir. So humble people. And each and every professor, especially in my department, not especially in my department, in all the departments, have been to the best places of the world. Stanford, MIT, working in Intel at more than 1 crore salary. There is a professor whose salary was more than 1 crore, and he left and he joined this department. Why? Because he wanted to have some research things, more extensive research, right? Wonderful people. If you sit with them, if they are speaking 10 words, out of those 10 words, 9 are can change your life. Out of 10 words, 9 words can change your life. This kind of knowledge based people. And the students, all the students are driven, self motivated. No one tells them to go to lab in 9 in the morning. No one tells them to stay in the lab 12 a.m. in the 12 in the night. They still do. Self motivated. They are not crying that PhD is hard or something. Self motivating people with the big dreams, ambitions, and very intimidating environment is there. Okay, if you are not working, you will not feel good, because everyone around you is working. No one here is making TikTok videos. No one here is doing any sort of bullshit which you can imagine. People don't have time for Instagram. They use Instagram for some time, but they don't have much time. Okay, all these things are outside the campus. Inside the campus, everyone is working, and work environment is so good. And as a PhD or MTech student, you are respected so much that you can't even believe. Okay, then my experience was I joined the new lab. So if you don't know what is new lab, so new lab is when your supervisor also joins on the same day as you join. Okay, so me and my supervisor both join on one August. So me and my supervisor both was new to the department, and we both got the our lab roughly on 20th August together. So he didn't knew what is going to be their lab, and I didn't know either. So department allotted some lab on 20th August. So just imagine there is an empty lab. Although our lab was not empty, our lab is shared between two supervisors. So half part was ours, but that was filled with crap, all sort of crap. Why? Because this lab was initially used to be the senior faculty. So then they gave this lab to the two junior faculties, and those two junior faculties are now sharing. So we cleaned everything from the very first day. Each and every tool, think about it, you have to spend lakhs of money, and you have to think how to spend. Not as supervisor, but as a PhD student, you have to spend the money, right? And then you have to think. Your supervisor is helping you, you don't know any idea. Your supervisor is teaching you as a teacher that this is what we are going to do, think what we will do. Okay, so very from the very first day I did set up the lab setting up, building the new tools, going to the engineers to tell them, uh, we want to our microscope like this, we want something coming from close to the microscope like this, we need something like that. Going to the PCB designers that we want PCBs. Okay, going learning the tools itself, right? And then giving the orders for the computers, giving the orders for the all sort of consumables in an experimental lab. There is so much which is you have to buy, right? Gloves you have to buy, chemicals you have to buy, then your glasswares is there, containers are there, electrical cables are there, right? All the new setups which are very advanced, which we are going to make in our lab, you have to think about everything. What are all the components which will go into that? You have to buy all the components. What are the specifications of all those components? So when you join in a lab where everything is set up, you don't know about these things. But when you make a new lab, then you think about each and everything from the very basic, from the point one. I have done that from the point one, how the lab is built. And trust me, in last, I think 7 months, we have spent more than 90 lakh rupees, 90 lakh to roughly to 1 crore. We have spent and building the things. Just yesterday I was doing the shopping. Then again you have to go to the markets, the special markets of Bangalore, and go and get the things from there. You have to import some stuff from abroad, you have to deliver some things, you have to go to the different labs of IISC and see how they have made the things, each and everything. And parallelly, you don't only want to put the lab, you also want to do the research, right? Because that is why you are there. Then in the meanwhile, doing the research in MNCF, NNFC, making the devices. So you see this device, usually people take at least 2 years to make such devices. If you go and ask any other people of my department, it has took them 2 months to learn this machine, which is electron beam lithography. But because I was in that mode of doing the work, I was able to make such beautiful devices in just 6 to 7 months. And even my coursework is not able over, and I am able to make such devices. So this may look like a simulation image, but this is an actual image, right? So all these things, amazing people are there, all the parties will keep on happening. So all the students versus teachers cricket match, right? Where does this happen? Happy environment is there, no mental problems. So teachers are playing. Just yesterday, finance minister, just imagine, finance minister of India. Can anyone give me the name? Finance Minister of India? Tell
Yes,
me.
Nirmala Sitharaman.
What is the
Nirmala
IIS, ISRO's director's name?
Sitharaman.
What is the
Yes,
ISRO's director name? Tell me.
yes, even
Okay. DRDO.
Yes, कैसे बनता?
DRDO G20. 20 nations out of many finance ministers were here. Many finance ministers of the G20 countries were there yesterday. ISRO director was there. And out of entire IISC, they only came to visit CeNSE. So just imagine, Finance Minister of India, along with G20 finance ministers, along with ISRO and DRDO director, comes to IISc and only visits one department, which is CeNSE. So you can imagine what they are thinking, why they came. And if some countries like this comes, they do not come empty handed, they come with a lot of huge amount of funding, MOUs and so on. So in next 5 years, those money is going to spend here. And if you are going to join this department, it is going to be the life changing game for you, right? No other, they went to no other department, just to CeNSE. Why? Because they see the future in the department. They know India has to lead in the semiconductor. And if India has to lead, this is a place where we need to train the people, right? CeNSE is not for manufacturing. We do not manufacturing chip. CeNSE manufacture people. They train the people so that they can go to industry and work there. They can have their own startups, right? So this was all about. Now I want to move to the career part. So before I move, any questions still here?
No, sir.
All done, all done. सबको समझ आया यहाँ तक? Yes, no, very quick.
Yes,
Yes,
sir.
sir.
Okay. So career after PhD.
Yes,
Let's
sir.
say, okay, I would say PhD, I put PhD, but I would also like to say MTech. Okay. MTech also I should put. It is not good to don't include MTech. That is also a good career. So what are the possibilities? First of all, if you want to come to CeNSE, okay, I will talk very strictly to CeNSE now. If you want to come to CeNSE, what are the opportunities you have? Number one, do the PhD. Get into PhD. Number two, do the Mtech, but where? One Mtech is nanotechnology, which is there from many years in the nanoscience department. One Mtech, which is going to open this year only, is semiconductor technology. So this is the first time nanotechnology department has offered this Mtech, semiconductor technology, right? So there are two Mtech programs and one PhD program. So let's say you get into PhD first. Let's see. Okay, let's assume you get into PhD. Will you get your PhD in 5 years? Yes, 5 years for sure. Your PhD will be done. Most probably. This is a trend of the sense. So once you do the postdoc, PhD, what you can do? You can go for postdoc abroad or India. I don't know anyone who has done postdoc in India after doing PhD from sense. All of them go abroad, and abroad means you can think of the best labs in the world, the labs of the Nobel Prize winners, the labs of the big grant winners, the labs which are known in the world to produce the high quality research in those labs. Wiseman, my supervisor was from Wiseman, MIT, Stanford, what you name it. Okay, because IISc itself has a world ranking of 133. And when you go for postdoc, you go even lesser than 100, world 100 institute. And when you go to such institute as a postdoc is not an education. Neither do PhD. PhD is not an education. It's not a study that you are doing. It's a work which you are doing. So the salaries in postdoc in abroad is very high. It is almost in USA, it is $1 lakh. $1 lakh is 80 lakh rupees in rupees. Okay, then in Germany, huge salary. Wiseman, huge salary. Good salaries are there. Not a rich salaries, but a very good salaries, right? This was about the postdoc. So very thing. This is for sure. 100% guarantee. Even if you don't do a very bad PhD here, guarantee very good group you will get. What next? Jobs in industry. So let me go to the next page for jobs in industry. This is for both Mtech and PhD. So there is a placement cell of the CeNSE itself. So CeNSE itself has a placement cell and the industry affiliation cell, which is in CeNSE. So in CeNSE is a place or an office which deals with the industry affiliation to connect with the industries. Every year, Mtech students are 100% placed in some of these companies. You can see the companies on the left. Samtem, okay, Recon, Applied Materials, Western Digital. So these CeNSE has a direct connections with them. They give all sort of emails or opportunities directly to CeNSE that give us your students 100% placement. What post? What is a post? So post is process engineers. Okay, engineer post. Process engineer is you have to think about the entire process, how you can do the process more efficiently. Scientists, okay, what is it going on there, how to develop the new process, how all kind of scientist and engineering post. It all depends upon what that company is doing. Okay, so if for example if Applied Materials is doing material fabrication, how to fabricate new materials, right? So all depends upon what companies doing. Optical companies are there, okay, and then electronics companies are there. All these companies need people, and of those standard which CeNSE has. So 100% placement. Can you guess the salary, average salary, after listening so much about the department
I think it
in
should be 40 lakh per annum, 40 lakh per annum. Right?
in India,
20
in
lakh.
Bangalore, in India,
20 lakh, 20 lakh.
in India, in Bangalore. Okay, so
20
think
lakh.
like this. Think like this. It is
20
not 20
कितनी
lakhs.
पैसे कितने
20
पैसे
lakhs. So this is okay, good number. So 20 lakhs. So you will get something like 16 lakh to 25 lakh, something in between. So even if you imagine very lower side, 16 lakh, almost 1.5 lakh per month. Who of you think this is less money? Just after Mtech. And in a job where you are not just a slave, you are doing physics, you are doing engineering, you are operating such high tools, and it is a starting salary. Do you think this is less salary or this
Mm,
is good salary?
I think this is far much away as far as I'm thinking.
Okay, so also in the
This
good
is
career,
very good, sir.
also a very good career, right? Not just a salary. You may get such salaries in software, right? But meaning of the life is gone, right? If you're not very much interested in software, then nothing is there for you. But here, you are doing physics, you are doing engineering, then you are getting such salaries. And even if you go to
Uh,
higher, like,
actually,
yeah, tell me.
actually, this is not about the salary. This is about the standard we are living in after the MTech from IISC.
Yeah, this is the salaries you are getting. Yes. Yeah. What you're saying? Living of standard? What?
I am saying that this is about the standard we will be living in the future after MTech.
Yes. 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 Everyone is getting this is in real it is happening. It's not some numbers I'm giving you. I'm a placement coordinator. Okay. If you want, I'm a placement coordinator. So I know the numbers and they also release the numbers. Okay. They don't release on website, but they give us the numbers. So these are the number which is happening. But still many people don't take the job. They go for PhD abroad after MTech. Why? Because they know right now I'm getting 1.5 lakh in India. Abroad, I will also get 1.5 lakh something. I know there is a currency difference. They can manage that currency difference. And after the PhD abroad, which is 3 to 4 years, they are going to get a much higher salaries and much higher positions. But let's say you don't want that. You only want job. Still, just take these salaries and do a work, do a job, get a job. Job is sure. If you are working nicely, your good grades are good. You are studying. You are a serious student. Good job, definitely, no problem at all. That's a guarantee. And also the new MTech which is starting, I think more jobs will be coming, right? Also, there is a stipend of 12.5 thousand per month in sense for MTech students. Not in sense, it's everywhere. Also, along with this, there are some industry fellowships also. So, sense students are somehow getting more money. Not all MTech students, but they choose few of the good students and then they give them more good money. Okay, this is all happening. Then this was the jobs after MTech. After PhD also, if you want to go into industrial jobs, I would say in the beginning roughly the same salary, but the post will be higher. In the beginning, I'm very specifically saying the salaries will be roughly the same, but the post will be higher. This you may not understand right now, but this is very nice for long term career. Okay, you may think, okay, the salary is same, so let's only do MTech, right? But if you have a PhD degree, then you have much more flexibility. You can go in academics, you can go abroad, you can go in this industry salaries, and it is just a beginning salary because company cannot hire you in the beginning at a very high salary. But the growth in the company will depend upon either you have the PhD or not. If you have a PhD in the companies, then you will be promoted to much higher levels very soon, very fast. That is a difference. But at the beginning, even after PhD, if you think these salaries are good, right, you are getting 2 lakh per month, not a small salary. 2 lakh is not a small salary, man. It's a very huge salary. Even after PhD, if you are getting this salary, very nice. But PhD, after PhD, you can even get academic posts. So I would say my inclination is still towards PhD. The reason being, PhD is a 3 more years of struggle, right? MTech is 2 year, PhD is 5 year. But just doing 3 years of struggle right now will help you, will settle your career. Then you don't have to think about doing any other degree. Then you are settled. Then you have to play. Then this is a playground for you. You can play around in any field. Okay, you can get into anything you want, right? Then you will have much more options than MTech. But for MTech people, once you get into company, shifting the companies and that will become little trickier, right? You may get initial good salary, but still I would be inclined toward doing PhD little bit more. But it's your call. If you want job just after MTech, just join MSc. After MSc 2 year MTech, get the job. Just get the job, good salary. But listen to me very carefully. All the departments will be coming to here, right? All the engineers will be applying. all the chemists will be applying, everyone will be applying, and you need to stand out. Your rank should be under 100 or at least 150 in just or in gate. Then only you will be called for interview, and interview you must have some good amount of study. Okay, you should show the good interest, only then you will be hired. Subject knowledge plus interest. And once you are hired here, just relax, then your life is set. That you don't have to worry, just worry about the coursework and everything. Lab work, coursework, research work, that's it. Placements will happen simultaneously along with that. Every week new companies are coming and giving the talk why to choose us. So different thing is happening, companies is coming to department and telling why to choose us. So yeah, they are telling to students, okay, don't go to that company, choose us. Okay, so this is the kind they want people. Only very few people in India knows about this because there is one department only to teach, right? So think about it. So this is what I wanted to tell. So other option, one option was job, one option was postdoc, one option, I have almost told you all the options. One option is left is startups. So Mtech students are not able to do the startup. The reason being 2 years is a very small time, but PhD students have opened a many new startups along with their supervisors. So few of them startups are which are opened in the CeNSE department only are dense power, Agnit. So I was telling about gallium nitride, right? So can anyone from today's I session I mentioned gallium nitride? Can you tell me what is the benefit of gallium nitride? Today I mentioned it. If you are listening carefully, you must know.
Sir,
It's a
post
gadget
silicon.
energy generation.
Usually, power to reduce, cut the power use.
Yes, power efficiency. So you know, see 5G and power conversion, right? So gallium nitride startup, dense power. Dense power is also again then universal nanofluidic devices. Nanofluidic devices is nano robots used to do the biological functions. Then small, big futures. I don't even know the detail about these startups. 3TM, thirdly, yes, I don't know how to pronunciate that. Nanotechnology for oral health. So it's a bio towards a bioscience towards, and this is opened by the PhD students along with the supervisors. So how these startups are getting opened in CeNSE? So I told you about InSense, right? InSense is there. So what they do, they give you office, they give you clean room to work, they give you initial money, they help you to raise the more money, they help you to connect to the Karnataka government, they help you to connect to the central government, they help you to give you connect you to the angel investors so that they can invest you in your money in your product, and they give you the 2 month 2 years of time so that you can stay in the CeNSE itself, use their offices, use their working space, use their clean room, and build the prototype, where prototype is a similar kind of what a product which is shown to give the proof of your concept, that whatever concept you have there is a proof of that concept. So then you can collaborate with the bigger companies. For example, Intel will be your angel investor. They not angel investor, they will be your investor, they will invest in you, you will build the product even more, then you will sell some equity, so on and so forth. Things keep on happening, right? So this is how you build a startup. It's a very tricky thing, but once you get into it, it becomes easy. Once you have the product, once you start researching, right? No one in the first year second year knows that they are going to build the project, but while doing the research you feel that okay, this has an application, because you are working everything in application, right? You are doing the experiments. So then you know, okay, I can actually build this into a product which can go into the hands of the consumers. And consumers here are not the people. No startup is dealing with the people directly to the people, they are dealing with the companies. So let's say Intel is making phones, and in the phone there are many components. I can make one of those components much better than anyone else. That's it, this is your startup. But this worth millions. Even if you can make one MEMS device which is very good in doing some particular applications of the mobile phones, then all the mobile phone companies need you. So you can imagine how big startup this is. You won't be hiring Katrina Kaif to do the ad on the mobile or on the TV, right? You are only dealing with the few top countries, top companies of the mobile phone. That's it. You are selling your product to them. No marketing involved. Only your product should be good, and you should have enough flexibility where you can build this product, and that is given in CeNSE. You have that opportunity. No one gives you office, no one gives you some sort of investment in the very beginning. For example, 20-25 lakhs in the very beginning, just build your product, right? This is beautiful. And if I speak about me, if we're talking about money, just money part, okay, so because this gives a lot of interest to the students. So on the 4th March there is going to be an open day. Open day is the thing in which entire IISc is open for school students, college students, local people, so that they can come and watch the different demonstrations put by the different labs. Okay, so entire IISc is celebrated, it's decorated, all there are stalls in all other departments. People are doing simple experiments, but here in the CeNSE, each lab gets 1 lakh to spend on this. You have to spend 1 lakh, not have to, but you think you have the ability, you have the chance to get spend 1 lakh. If you have something in mind, make of something big, spend this money, department will give you the money, no questions asked, only your supervisor is the boss. Make this product. And why 1 lakh? Not just to give the money, it is so that students actually can get excited about the semiconductor industry, can get excited about the nanoscience, nanotechnology, so that we can actually have a ability to make such good demonstrations, right? And they will be coming, they will be watching that. So this is something very beautiful. And just imagine, just think about me, I am the only student of my supervisor, only I am there. So I am only responsible for thinking that where this money should go, how I will how I will spend this, what demonstrations I'm going to make. So one day I'm doing work in clean room, next day I'm doing work in the MNCF where I'm miring, third day I'm going to packaging lab, fourth day I'm making the PCBs, fifth day I'm working in my lab, sixth day I'm thinking about open day, seventh day I'm talking with you. So it is so happening, life is there that you feel alive, you feel that you are spending your youth in something very meaningful, right? My officially salary is only 31,000 PhD stipend, right? Because this is because of the Indian government, every PhD student in the world, in India, should get this salary only. But I know I'm department is spending so much money to train me, which is going to convert into so much more money in next 3-4 years. When I graduate from here, I know this salary is going to jump very high because so much training I'm getting, and it is for sure it is happening. It's not something uncertain, it's 100% guarantee based on the statistics of the people before me. I'm not doing bad PhD, I'm even doing good PhD than that, so I will definitely get more good results than that them. So this is all about this. So you have all the opportunity. If you have businessmen in you, open a startup. If you want job, do Mtech or PhD, get the job. If you have a researcher in you, there are many interesting people, research is going on, huge amount of research, go to the best labs of the world after here. Okay, it is also one of the best labs. Even after that, go to more best labs, more best facilities, more best people, then again come back to India and serve the nation. Then, so researcher in you, go to there. All whatever is in your mind, you will get whatever is there, right? So I have already shared my experience. Yeah, in my experience, I didn't mention one thing actually. So this cubicle you see, every PhD student get a cubicle. So this is my cubicle. This is my sort of office where I never sits because I'm never free. But this is officially my office, right? So you can see my sitting space, right? So this is something which I measured using Raman spectroscopy. Very simple experiment. You can do in 2 hours. This is something I built. This is very complex. Okay. This takes some time, and this is me in the clean room. Right now, phones are strictly banned, so I cannot take phone inside. But initial days, it was not that strict. So I took the image of me inside the clean room. Admission process I already explained you. You must have GATE or JEST exam for MTech, GATE or JEST for MTech, and GATE, JEST, NET, or Inspire for PhD. So okay, so MTech I think jest is also acceptable and gate is also acceptable. So your rank should be, I would say, less than 150. Less than 150 for sure. Let's say you do not get into CeNSE department. There are other departments also which are possible. One is applied physics and instrumentation. If you're in such departments, still you can join such labs which are related to nanoscience, and you can still come to nanoscience department and work in the clean room and so on. Many people do that. You can also get to physics department, that is always there. You see the cutoff for physics department is 60 because many people know about this, and the cutoff for science is 150 because not many people know this, right? So you have an opportunity. Still not many people know. In this meeting there were 50 people. Other than that, more 50 people will know. So not many people in India know about this. So you still have a chance. So get a good just rank, 150 something. Very good. You will get a good chance to come here for the interview. Then whatever happens in interview, it happens. That depends upon that day, right? So for MTech, I think for MTech, I think it will be cutoff will be around 200 only in gate or okay. It will not be same as PhD. Less, more cutoff will be more rank cutoff will be there because MTech is usually preferred after the PhD. Okay, but anything can happen. I cannot guarantee these numbers. These numbers were of my time. Now numbers will definitely change. Okay, every year it changes. Either it goes down or up. It all depends, right? Then I think I would like to thank you all. If you want to connect with me, you can connect here. You can join our Telegram channel. You can do the preparations with us, just preparation, net preparation, gate preparation. You can visit our website or you can call me. So before calling, I would expect you that you message me first before calling. That I want to have a conversation with you. Then we can fix a time and we can have a call. Or you can drop me an email here. So I think this was all about I wanted to say. Now I am open to the questions. But before that, if you're watching this on YouTube, subscribe to the channel. Why? Because I don't care if you subscribe or not, but huge amount of good content is coming and it's already there also. So if you subscribe, there are many fields which no coaching or anyone knows. This is only based on the experience. You will not hear about CeNSE department anywhere else from anyone else. You can, I bet you, I can give you open challenge. Okay, so these kind of things you will go only get here in our channel. So stay connected, at least stay connected. It will help you, right? So now I'm open for questions for the live session, and I will stop the recording here. I don't want to record the questions of the students so that they can openly ask the question.